and then record again. Okay. The new section is section 3.8, Newton's method. It's a method to approximate the roots of a function. So I guess a motivational example is something like this. Let's consider the function x minus 1. If I ask you what is a root, do we know how to find the root of this function? We don't have a formula for this for finding the root of this function, right? So difficult to find roots. But what we know is the following. We know that when I plug in 0, I get -1, which is less than 0. And when I plug in 1, I get 1, which is positive. And so intermediate value theorem guarantees a root. It guarantees a root in 0 and 1, but it doesn't tell you what is the root in 0 and 1. Does it make sense? Okay. Now, here's the formula for the, okay, repeat what? So I'm saying that what we know about this function is when you plug in 0, you get -1. When you plug in 1, you get 1. So one of them is negative, the other one is positive. So if you go back to see what was the intermediate value theorem, it says that there exists a root in between 0 and 1. So it guarantees a root from in between 0 and 1, but it doesn't tell you what is the root in 0 and 1. That's what we are trying to do in this section. We're trying to approximate the root. So here's the formula. For the Newton's method. So usually I will start by describing how to deduce that formula, but because we are out of time, I don't want to go into details. But the idea is you want to find a sequence of points. And they're called xn, x sub n, using the formula xn equals xn minus 1 minus f of xn minus 1 divided by f prime of xn minus 1. That's a formula. So usually in your quiz or in your exam, you would be given the first point, and then you'll be asked to compute the second point, the third point, the fourth point, and that's it. But the idea is as n gets larger, xn gets closer to the real root. So if you do more points, the approximation would be more accurate. That's what I'm saying. Does it make sense? And that's a formula you need to remember. Okay, let's look at one question. So I'm using the same example here. I'm using x cubed plus x minus 1, the same example as before. And I want to approximate the root up to 3 decimal places. I'll explain in a moment what does it mean. Okay. So the intermediate value theorem tells you that a root is in 0 and 1. So I can pick my x1, the first one, to be any point from 0 to 1. So let's pick 0.5. I meant to write 0.5. Let me say this again. So you can pick any points you like. I'm picking the first point to be 0.5. It doesn't have to be 0.5. You can pick 0.1, 0.2, 0.777, whatever, as long as it's in between 0 and 1. Is x 0.1 or is x n? No, I'm calling x1. So x1 is the first point. x2 is the second point. x3 is the third point. And I'm going to use this formula to find the second point. So using the formula, I know that x2 equals x1 minus f of x1 divided by f prime of x1. F of x1 should be easy. You just plug 0.5 into the original function. But f prime of x1, I need to take the derivative. So let's compute the derivative. The derivative is 3x squared plus 1, right? And so x2 equals, using this formula, and then you plug x1 equals 0.5, you get that x2 equals 0.5 minus 0.5 cubed plus 0.5 minus 1 divided by 3 times 0.5 squared plus 1. And this is a section that you can use a calculator, and I'll let you compute that. You get 0.714286. Okay. X2. One thing I should mention that is when doing a homework, you want to include as many decimal places as you can. So if you get like 10 decimal places, try to write everything down. You don't want to round up. You don't want to round up in the beginning. So write as many decimal places as you can. All right, so x2 equals that. And I want to find x3. So x3 equals x2 minus f of x2 divided by f prime of x2. So plug your x2 into your function and then plug your x2 into your derivative. I'll let you compute that, but you're going to get 0.6831 8. And doing this over and over again, you get that x4 is 0.682328. And using x4, you can compute x5, which is 0.68232781, I think. And the original question was approximate the root up to 3 decimal places. By that I mean you stop the process when the last 2 points are the same up to 3 decimal places. So x4 and x5, they are the same up to 3 decimal places, right? They are both 0.682. So the final approximation is 0.682328. Is it okay? Questions? How did I get those numbers? Calculator. Put into your calculators. Any other questions? Is the root always 0 and 1? No. It depends on your question. Okay. One more example. So the question is find the root of the equation cosine of x equals x up to what makes you start at 0.5. I say you can pick any point as long as it's in between 0 and 1. I picked that because it's in the middle. It doesn't have to be in the middle. Does that answer your question? Okay, so first you use intermediate value theorem. Yes. To verify, well, to at least verify the exists a root. I'll pick a number in between. Yes. Any number, yes. All right. Any other questions? All right, second example is I want to find the root of the equation cosine of x equals x. Again, up to 3 decimal places. All right, so it's an equation like that, cosine of x equals x. So the function that I'm interested in should be cosine of x minus x, right? Which means the derivative is negative sine of x minus 1. Is it okay? Okay, now we know that f of 0 is 1, right? When you plug in 0, cosine of 0 is 1, and then x equals 0 is 0. So 1 minus 0 is 1, which gives you positive. And if you put in pi over 2, cosine of pi over 2 is 0. So you get negative pi over 2, which is negative. So intermediate value theorem guarantees a root in 0 and pi over 2. Is it okay? Now pick any number you like as long as it's in between 0 and pi over 2. So pi over 2 is around, I think, around 1.7 something. No, I'm looking at this one and this one. Another question is, will WebWork accept decimal places or only fractions? Do you mean the number you pick, or do you mean the 2 points, 0 and pi over 2? The answer, it should be in decimal places. Okay. All right, so pick any number in between 0 and pi over 2. Pi over 2 is around 1.75, I think. No, sorry, 1.57. So you can pick I'm going to take 1.5 because that's what I did in my notes. So x1 equals 1.5, but again, you can pick any number in between 0 and 1.57. Okay, and then you use the formula. So the formula says that if I want to find x2, x2 would be x1 minus f of x1 divided by f prime of x1. So you plot 1.5 into your original function as well as your derivative. You should get something. I don't think I have that in my notes. But anyway, so this is the formula. So plug that into the formula. And when do we stop? When do we stop this process? Okay, so you stop the process when the last two numbers, the last two approximations you get agree up to 3 decimal places. Otherwise, you have to keep going. So I do not, as I say, I do not have this in my notes, but that's the idea. So just plug 1.5 and then keep doing that over and over again. Any questions? Okay, I need 1 more second before you go. No, I don't mean you have to keep plugging in 1.5. I mean, once you find x1, sorry, once you find x2, you put x2 into your x3, and then put x3 into your x4, so on and so forth. Okay. But you stop the process when the approximations agree up to three decimal places. Any other questions before I let you go? All right, that's it.